I'm going to go over two of the problems from the worksheet I distributed in class called Collisions and Explosions in 1D. The first one I'm going to go over is number 3. It starts with a fisherman, has a mast, blah, blah, blah. So basically what it comes down to in this topic is that unless there are outside forces, the momentum in a system stays the same. So a statement of that is the net momentum of the system before the interaction equals the net momentum of the system after. In number 3, we have a situation where they have the fisherman and the boat, well, we'll call them A and B before I get into the actual math. So we're given the mass of the man is 122 kilograms, the mass of the boat is 300 kilograms. They're stationary at the dock, so they both share an initial velocity. The fisherman steps forward off the end of the boat at 5 meters per second, so I'll call that positive. And what's the velocity of the boat as the fisherman steps out? Okay, so they share an initial velocity and have different final velocities. Now, yes, I recognize that you could do this pretty quickly with a proportion or a ratio, but I want you to practice going through the steps and really getting the conservation momentum equations solidly in your head, because they are going to get more complicated than this. So the most basic statement of conservation of momentum is that the momentum of object A before plus the momentum of object B before equals the momentum of object A after plus the momentum of object B after. In this case, since they share an initial velocity, they're basically acting as a single unit before. So since momentum is mass times velocity, I can condense these two terms because I can pull out that velocity term. They share initial velocity. They have different final velocities though. Since we know that the initial velocity is 0, this whole term is going to go to 0. We have a sum here, so obviously the final velocity is going to be negative because they're going to go opposite ways. And I didn't bring my calculator down, so I don't know what that is, but that's how you would do number 3.